For a century, our relationship with fueling our vehicles has been, well, entirely static. Like you watch a needle on the dashboard drop toward E, you drive to a designated concrete lot, you pump a flammable liquid into a tank, and you leave.
Right. It's just, we just accepted that this is how transportation works.
Exactly. We never questioned it.
Because the infrastructure is literally bolted to the ground. I mean, you have to go to the energy because the energy is never coming to you. It's a highly centralized, rigid distribution network that honestly hasn't fundamentally changed since, like, the Model T.
Right, but then you start looking at the future of electric mobility, and that rigid gas station model doesn't just evolve. It completely shatters.
Oh, absolutely.
We are looking at a landscape that is rapidly becoming fluid, decentralized, and honestly a little bit mind-bending.
Yeah, we are witnessing the absolute definition of an infrastructure paradigm shift. The grid is becoming this dynamic, distributed web of power where the vehicles themselves are active participants. They aren't just passive consumers anymore.
Okay, let's unpack this. Because whether you are an EV owner who is just completely tired of pulling up to broken public chargers, or maybe you're a municipal policy buff, or you're just insanely curious about the future of energy, this deep dive is going to rewire how you look at the streets, the grid, and even, honestly, national security.
It really connects all those dots.
It does. And to figure out how this is happening, we gathered a fascinating stack of evidence for you today. We are pulling insights from recent municipal strategy notes out of Massachusetts, a California legislative analysis focused on emergency preparedness.
Which is super relevant right now, by the way.
Oh, absolutely. Plus, we've got press releases from the front lines of mobile charging and a truly eye-opening operational report from the NATO Energy Security Center of Excellence.
Yeah, and I know it might sound like a sort of scattered stack of sources, right? Like Massachusetts City Planning and NATO, but they all converge on the exact same reality. The battery sitting in your driveway is about to become a lot more than just a way to get from point A to point B.
Yeah, so let's start with the most relatable hurdle to this whole transition, which is charging in a dense city. I mean, if you live in an apartment and you don't have a driveway, how do you charge your car?
Right, the classic urban charging problem.
Because we obviously can't dig up every single sidewalk in the country to lay heavy-duty utility cables. It's just not going to happen.
No, digging up sidewalks, which is known in municipal planning as trenching, is prohibitively expensive. And honestly, it's a logistical nightmare.
Because they have to tear everything up, right?
Exactly. When a city trenches, they aren't just, pouring new concrete. They have to navigate existing water mains, fiber optic cables, gas lines. You're dealing with street closures, really complex permitting, and massive utility connection delays.
Which brings up a brilliant workaround from those Massachusetts municipal strategy notes.
Yeah.
There's a startup mentioned in there called It's Electric, and they approach this totally sideways.
Yeah, their model is really interesting.
Right, because instead of bringing new power lines from the grid to the street, they tap into the buildings right next to the sidewalk. They basically look for property owners with excess electrical capacity of about 40 amps.
Which, just for context, is roughly the size of a large electric stove.
Oh, okay. So not a crazy amount of power.
No, not at all. And the genius there is the concept of going behind the meter. They are utilizing the electricity that is already flowing into the building at the correct voltage.
So they don't even need the utility company to come out.
Exactly. By avoiding the need for a brand new utility connection and a separate meter out on the street, they bypass months of regulatory delays.
And the business model totally removes the friction for the property owner, too. Like, it costs the city and the landlord absolutely nothing to install.
Zero upfront cost.
Right. The company handles all the hardware, and the property owner actually gets 20% of the revenue from the charging sessions. Plus, they solve the whole physical clutter problem with a detachable cable.
Yeah, that's a huge deal for city planners.
Right, because you bring your own cord, you plug it into the street unit, and then into your car. When you drive away, there is no bulky cable left on the sidewalk for snowplows to mangle or, people to trip over.
It addresses the reality of urban wear and tear, because stuff on the street gets destroyed.
Totally.
And another company in those notes, VoltPost, tackles this by repurposing a piece of infrastructure that already has power and exists on literally every single block, the lamp post.
Yes, I saw that.
They basically upgrade the post to support up to 2 charging ports.
I love this concept because it reminds me of how cities repurposed old public payphone booths into Wi-Fi hotspots.
Yeah, exactly the same principle.
You take a defunct or single-use piece of city property and you just give it a modern utility.
Yeah.
But I have to imagine, like, dealing with municipal utility poles isn't just a simple hardware swap, is it?
No, that is the harsh reality outlined by the utility companies in those exact same meeting notes.
Okay, yeah.
National Grid actually ran a pole-mounted charging pilot in Melrose, Massachusetts. And on paper, installing a charger on a pole was 70% cheaper than digging a trench for a ground-mounted station.
Wow, 70%. That's massive.
Massive savings. But the administrative friction was just grueling.
I assume because multiple entities own or, like, regulate different parts of a single utility pole.
Precisely. The third-party attachment process requires extensive pole surveys. You have to calculate wind shear, weight loads, proximity to existing transformers.
Oh, man.
Yeah, and then you add on annual licensing fees to the city and the exorbitant cost of specialized insurance required to attach consumer hardware to high-voltage municipal property.
It sounds like a total headache.
It is. Furthermore, VoltPost noted that typical lampposts run on about 100 volts. So to provide meaningful level 2 charging, they have to work with the utility to step that up to 240 volts.
While making sure the streetlights don't just go out.
Exactly, while somehow ensuring the streetlights don't dim when a car plugs in.
It is a massive bureaucratic maze. And even if you solve the hardware and you get past all the red tape, you still have to manage human behavior.
Always the hardest part.
Always. The notes mentioned Somerville, Massachusetts. They had to institute a 25-cent per kilowatt-hour fee on their public chargers under a program they called Charge for Charge. And before that, the chargers were totally free.
Right, and if public infrastructure is free, it gets abused.
Exactly. People were treating the spots as long-term free parking.
Because without a financial incentive to move, why would you? Implementing that fee was literally the only way to encourage space turnover and curb localized vandalism.
Okay, so if trenching is too expensive and attaching chargers to lampposts is drowning in municipal red tape, the only logical pivot for the market is to just stop waiting for the grid entirely. You have to decouple the charger from the earth and bring the power directly to the car.
Yes. This completely flips the historical model of energy distribution. We are seeing the rise of MCAS.
Okay, yeah.
Yeah, mobile charging as a service.
Right. So the Massachusetts notes highlight a platform called SparkCharge. They operate completely above ground without any permanent grid connection.
It's basically delivery for electricity.
Exactly. You open an app, you drop a pin on your location, and a technician literally drives a portable battery system to your parked car. But looking at the economics and the source material, the cost is notably higher.
But it's not cheap.
It ranges from about 60 cents per kilowatt hour for a standard commuter car, all the way up to $1.20 for large commercial freight vehicles. That is significantly more expensive than just plugging in at home.
It is a premium price, absolutely. But you have to look at the logistics they are solving, especially for commercial fleets. The press releases in our stack show massive capital flowing into this sector.
Oh, totally. Like BeeCharged EV securing major funding.
Right. They just got funding to deploy commercial mobile fleets, and Pioneer Power Solutions landed a $10 million award for their eBoost 175 systems. What's fascinating here is that Pioneer is literally building off-grid 180 to 500 kilowatt power hubs.
Wait, a 500 kilowatt hub? That is basically a localized power plant. You are bringing a massive shipping container-sized battery to a parking lot.
You have to, because grid infrastructure delays are the single biggest bottleneck for commercial electrification right now.
Okay, how so?
Think about it. If a delivery company buys 50 electric vans today, their local utility might tell them it will take 3 years and millions of dollars to upgrade the neighborhood substation just to support that kind of power draw.
3 years. They can't wait 3 years to run their business.
Exactly. So by utilizing an off-grid mobile hub, which, by the way, is often trickle-charged by solar or cleaner microgrids, that business bypasses the utility wait times entirely.
I see.
They trade a higher per kilowatt cost for immediate operational readiness.
Okay, that makes a ton of sense. But this decoupling from the grid isn't just an economic workaround to avoid utility delays. It is rapidly becoming a literal matter of public safety.
Oh, 100%.
Because mobile charging is stepping in as a critical lifeline during climate emergencies.
Yeah, the intersection of energy distribution and emergency management is becoming starkly visible. When the grid fails, transportation cannot fail with it.
Right. So the notes mentioned SparkCharge actually deploying their mobile units in Texas following Hurricane Beryl. And the Alternative Fuels Data Center actively tracked mobile chargers that were deployed along evacuation routes in Florida for Hurricane Milton.
It's becoming standard emergency protocol.
It is, but the pending California legislation, AB 2543, that really exposes the vulnerability of our current system.
Oh, that bill is a wake-up call.
Right. This bill is proposing that operators of direct current fast charging stations, like the massive public chargers on the highways, they might be legally required to submit emergency plans and provide backup power options.
Because California is attempting to mandate resilience, they recognize a terrifying operational gap.
What's the gap?
Well, during extreme wildfire conditions, utility companies frequently initiate public safety power shutoffs.
Right, the PSPS events.
Exactly. They intentionally de-energize the power lines to prevent high winds from snapping a live wire and sparking a fire.
So ask yourself this. If you are fleeing a wildfire and you are relying on a public fast charger along the evacuation route, what happens when the utility company intentionally cuts the power to that exact region?
The charger goes dead right when the population needs it most.
It's a terrifying scenario.
It really is. And the bill analysis cites a UC Berkeley study showing that just on a normal day, 28% of public fast chargers in the Bay Area were already broken or inaccessible.
28% on a good day.
On a completely normal day. So to combat this generally poor reliability, the federal government created the NEV program, the National Electric Vehicle Infrastructure Standards, and that legally mandates a 97% uptime for federally funded chargers.
And this is crazy. There is a massive loophole in that 97% requirement, isn't there?
A critical one. The NEV uptime calculation explicitly excludes downtime caused by natural disasters or utility shutoffs.
That is wild. The exact moments when the public desperately needs the infrastructure to escape a disaster are the exact moments the charging operators get a free pass if their equipment stops working.
Yep. AB 2543 is trying to close that exact gap. It would force the Office of Emergency Services to map out crucial charging sites based on population density and evacuation corridors.
Okay.
And the operators of those specific sites would have to plan for off-grid backup power, which the bill defines as backup generators, or the rapid deployment of those mobile charging hubs we were just discussing.
So we are essentially treating EV chargers like hospitals now.
That's a great way to put it.
We are acknowledging that they are so vital to human survival that they require mandatory backup generators and emergency triage plans.
Because transportation is a baseline human need during a crisis. As the vehicle fleet transitions to electricity, the power grid becomes the sole provider of that baseline need. It just cannot be allowed to fail.
Right. But to survive these harsh emergency conditions and to efficiently utilize these massive off-grid power hubs, the technology inside the cars has to evolve just as fast as the infrastructure outside.
It's a two-front war, basically.
Yeah. And we have an incredibly detailed operational report from the NATO Energy Security Center of Excellence that breaks down the future of battery chemistry.
NATO is monitoring this super closely because we are currently in a transitional phase. I mean, lithium-ion prices have plummeted over the last decade, and their energy density is maxing out around 200 to 300 watt-hours per kilogram.
Which is good, but not great.
Right. The tactical advantages for the military rely on what comes next.
So the report focuses on two major breakthroughs. The first is solid-state batteries.
Yeah.
If I'm understanding the physics right here, the main limitation of our current batteries isn't the lithium itself, it's the liquid inside the battery that moves the energy around. That liquid is the bottleneck.
Exactly. The liquid electrolyte in current batteries is highly flammable. If the battery is punctured or overheats, that liquid can ignite, leading to a dangerous chain reaction called thermal runaway.
Which you see in those crazy battery fire videos online.
Exactly. And it also limits how fast you can push electricity into the battery. If you charge too fast, you risk boiling the liquid or forming these microscopic metal spikes called dendrites that literally short out the cell.
Oh, wow. So solid-state batteries just replace that liquid with a solid material.
Yes, usually a solid ceramic or polymer separator. By removing the flammable liquid, you inherently remove the fire risk.
That makes sense.
And because the internal structure is vastly more stable, you can pack the energy much tighter, so increasing the density, and you can blast it with high-voltage fast charging without degrading the battery's lifespan.
So it's safer, lighter, and incredibly fast to charge. Okay, the other breakthrough NATO geeks out over involves the battery's anode. Currently, we use graphite, but they want to switch to silicon because silicon can hold roughly 10 times the amount of energy.
10 times. It's massive.
But the report notes that silicon has a massive physical flaw when it absorbs electricity.
It expands violently.
Violently.
Yeah. When lithium ions enter a solid silicon anode during the charging cycle, the silicon swells by up to 300%.
Wait, 300%.
Yeah. And then when it discharges, it contracts back down. Imagine a solid pane of glass expanding and shrinking like that.
Right.
After just a few cycles, the silicon physically shatters and the battery dies.
Okay, but scientists figured out how to engineer the silicon on a microscopic level so it doesn't shatter. They basically turn it into a sponge, right?
That is an excellent way to visualize it. By engineering nanostructured silicon, they created these microscopic empty voids within the material. So
Yeah.
when the lithium ions enter, the silicon expands internally into those empty spaces rather than pushing outward and fracturing the outer structure. This sponge-like architecture preserves the integrity of the anode while unlocking just massive energy capacity.
That is brilliant. And here's where it gets really interesting. Once you put these highly dense, rugged batteries into a vehicle, the way that vehicle interacts with the world changes entirely through vehicle-to-grid, or V2G, technology.
Yes. If we connect this to the bigger picture, V2G is the linchpin of the decentralized grid we discussed earlier. It allows bidirectional energy flow.
Meaning it goes both ways.
Exactly. The vehicle doesn't just pull power, it can push power back out.
Right. So the NATO report mentions Nissan's Leaf to Home project in the UK, where a parked electric car can physically power a house during a blackout. Or more commonly, it can sell its stored energy back to the local grid when electricity is really expensive, and then buy it back at night when it's cheap.
What's fascinating here is how this alters the fundamental economic value of a vehicle. I mean, a consumer car sits parked and useless for roughly 95% of its lifespan.
95%.
Yeah, it's just an idle, depreciating asset. But V2G transforms that parked asset into a distributed energy storage unit that actively generates revenue and stabilizes the local grid.
And this is where the NATO report pulls everything together. Because if UTG and these advanced batteries are useful for a civilian grid, they represent an absolute tactical revolution for the military.
A total game changer.
I think the real insight here is that the civilian environmental movement and military tactical planners have accidentally aligned on the exact same technology, just for entirely different reasons.
That is a really profound realization. The NATO operational energy concept from 2024 introduces a doctrine called energy superiority.
Energy superiority.
Yeah, the military is not adopting electric vehicles to reduce their carbon footprint or appeal to environmentalism. They are adopting them to achieve total operational dominance.
Right. The report lays out exactly why they want these vehicles, and the number one reason is stealth. I mean, anyone who has ever stood near a diesel military Humvee knows they are deafeningly loud and pump out massive amounts of heat.
Internal combustion engines generate massive acoustic and thermal signatures. On a modern battlefield, heat is a death sentence because drone infrared sensors can spot a hot diesel engine from miles away.
Wow. Yeah. So electric drivetrains offer an unparalleled tactical advantage because they are nearly silent and they run significantly cooler, virtually erasing those signatures.
That is wild. And they are weaponizing the V2G technology to protect their supply lines, too. Right now, to run the computers and radar at a forward operating base, the military has to keep diesel generators running 24/7.
Which is incredibly risky.
Right, because that requires constant convoys of highly flammable liquid fuel driving through hostile territory.
Moving liquid fuel in a war zone is one of the most dangerous, resource-intensive logistical operations a military undertakes. Those convoys are massive targets.
Absolutely.
But if your tactical vehicles are electric and equipped with V2G, the vehicles actually are the generators. An idle fleet parked at the base forms a silent, self-contained microgrid, drastically reducing the need to truck in diesel.
Okay, but zooming out to the massive scale of this, like building electric tanks and heavy off-grid power hubs, we have to look at the manufacturing side.
Because a lot of people ask, does building a massive armor-plated electric vehicle, or even just a heavy civilian electric SUV, actually benefit the environment when you factor in mining all that lithium and silicon?
It's a fair question, and the NATO report imparts impartial data from life cycle assessments, or LCAs, to answer exactly that.
Okay, what's an LCA?
An LCA measures the total footprint, so mining the raw materials, the energy used in manufacturing, the vehicle's entire operational life, and its eventual disposal.
So they measure the whole cradle-to-grave impact.
Yes. And the data confirms that battery electric vehicles, even the very heavy ones, when charged with a renewable energy mix, reduce greenhouse gas emissions by up to 80% compared to internal combustion engines over their total lifetime.
Okay, so the data is pretty clear on that.
It is. The operational efficiency of an electric motor just vastly outweighs the heavier upfront manufacturing footprint.
But the military also cares about the raw materials, right? They don't want to rely on vulnerable global supply chains for lithium.
Which is exactly why sustainability has become a strategic military priority. The report highlights the rapid acceleration of closed-loop recycling.
Like what Tesla is doing.
Exactly. Tesla's Redwood Materials facility in Nevada isn't just crushing old batteries. They are hydrometallurgically extracting up to 95% of the pure critical elements, the lithium, cobalt, nickel, and flare, and injecting them directly back into the domestic supply chain to build new batteries.
Wow.
Furthermore, manufacturing plants like VW's Zwickau facility in Germany are now running on 100% renewable energy.
So they are essentially greening the entire supply chain from the factory floor to the recycling bin to ensure they never run out of materials.
Precisely.
So what does this all mean? If we trace the path we've taken today, it's wild. We started on a city sidewalk trying to bypass municipal red tape by plugging into a lamppost.
Yeah, the volt post stuff.
Then we cut the cord completely, looking at mobile power hubs that bring the power plant directly to the parking lot. We saw how California is forcing the industry to build disaster resilience so we can actually evacuate during a wildfire. And we ended on the battlefield, where microscopic silicon sponges and solid-state batteries are providing acoustic stealth and turning military camps into silent microgrids.
It just really demonstrates that the transition away from fossil fuels is no longer just an automotive story. It is a story about grid resilience, economic efficiency, and national security.
It really is. And the next time you walk past an EV plugged into a street lamp, you shouldn't just see a charging cable. Realize that you are looking at the very edge of a massive, interactive, resilient power web that is actively reshaping how the world operates.
Absolutely. And if we connect this to the bigger picture, I will leave you with a final thought to consider.
Okay, let's hear it.
If V2G technology allows a car to buy and sell its own power, and autonomous driving is rapidly approaching, could we see a near future where your car automatically unplugs itself in the middle of the night, drives to a neighboring town experiencing a localized blackout, sells its stored energy at a massive premium to support their grid, and then drives back home and parks itself in your garage before you even wake up?
Wow. That is a staggering thought. You go to sleep, and your car autonomously goes to work trading energy for you. Well, thank you for joining us on this deep dive. Keep questioning the world around you, and we'll catch you next time.